Hi, I'm Jason Palidwar, an account manager with Iridian Spectral Technologies, and I'm here at Defense and Commercial Sensing in Baltimore. Today I'll be clearing the air regarding challenges associated with mid-wave infrared systems and the optical filters used within them. From environmental sensing to crowd control and proximity detection, and the Internet of Things, sensors and detectors have become a more and more ubiquitous part of our everyday lives, enabling us and our devices to better understand and interact with the world around us. Use of the mid-wave infrared region allows detection of phenomena such as thermal imaging and airborne gases that are not easily detected in the visible or near infrared. The mid and long-wave infrared has historically been the domain of the defense industry due to the restricted access and high costs of the detectors involved in the systems. However, as access to these detectors has opened up, the costs have gone down and a lot of these commercial applications have evolved. And this has driven the need for filters to address these needs. At Iridian, we're focused at this show on mid-wave infrared bandpass filters for non-dispersive infrared and photoacoustic spectroscopy, as well as multi-zone filters for multispectral imaging in the mid-wave infrared. Similar to the visible and near-infrared region, optical filters in the mid-wave infrared serve the functionality of wavelength selectivity, allowing maximizing signal-to-noise at the detector. This is achieved by having a high transmission and narrow bandpass region, but additionally, these mid-wave infrared systems are often used in quote-unquote real-world environments. So there's a high requirement for durability, reliability, and stability over the temperature and humidity ranges of the natural environment. To address this, filter manufacturers like ourselves have had to develop new materials, both coating materials and substrates, as well as the processes to put these together to provide these high transmission narrow bandwidth filters with high reliability. And at Iridian, this is largely a solved problem, and so we're now able to apply these materials and processes to these applications. As customers have approached us in the mid-wave infrared, there are two areas that have been particularly challenging with regard to specs. The blocking bandwidth associated with mid-wave infrared filters is one of these. The sources in the mid-wave infrared may extend from the UV out to as far as 30 microns. However, the detectors used in these systems and the optical systems around them may restrict the actual wavelengths that the detector can see. If customers can specify a narrower blocking range, we can design less complex filters and perhaps use less costly substrates so we can provide increased performance with lower cost to our customers. Similarly, surface quality has been a key cost driver for specs. In the visible and near-infrared region, in imaging in particular, we'll see scratch-dig specs of 60-40, 40-20, or even better. But in the mid-wave infrared, small defects like this may not even be visible due to the long wavelengths used. Additionally, as a lot of these systems are actually doing sensing as opposed to imaging, the small cosmetic defect may be invisible to the detector. Customers can relax the scratch-dig specifications to 80-50 or even more relaxed. We can have higher yields in our production processes for these relatively thick and complex filters and pass along those lower costs to the customers. These are just a few of the challenges associated with mid-wave infrared systems and the filters used in them, but we're happy at Iridian to discuss with customers your particular needs and address any challenges that you might have. Thanks.